Hello, sixth graders, and welcome to the final lesson, lesson number 7 in chapter 5, where we're going to be talking about solving fraction equations, and specifically, we're going to be using multiplication and division in this section. All right, we're going to start and get right into the examples here so we can see a bunch of them today and kind of get the hang of it. All right, so just like in previous lessons where we're solving equations, we have to remember to ask ourselves that question, what is being done to my variable? And then how do I undo that? All right. In this instance, the first equation, I have 3/5 j. Remember, when any number is smushed right up next to a variable, that implies multiplication. So we are multiplying in this first problem. That's what's being done to j. How do I undo that? Well, the opposite of multiplying is dividing. So what we need to do is we need to divide both sides by, well, j is being multiplied by 3/5, so we need to divide by 3/5, right? And what I do to one side of my equation, I need to do to the other. Right, so let me make this a little bit more clear. 3/5 j equals 25. I need to divide by 3/5 on both sides of my equation. Because anything divided by itself is 1, and I'm left with 1j, which is what I want. Remember, I want to isolate my variable, equals. Okay, now we flash back to a couple sections ago where we were dividing fractions. And how do you divide fractions? Well, remember that dividing fractions, use the acronym KFF. Keep the first fraction the same, flip your division to multiplication, and flop to its reciprocal. So we multiply by the reciprocal when we divide fractions. Right? The reciprocal of 3/5 is 5/3. We multiply by 5/3, which is the reciprocal of 3/5. Okay, so we take 25 and we multiply that by 5/3. So 25, which is the same thing as 25 over 1. You can make any whole number a fraction by putting it over 1 and multiplying by 5/3. Okay, when I do that, 25 times 5 would give me 125 over 3. 1 times 3 on the bottom is 3, so 125 over 3. Okay, and how many times would 3 go into 125? Well, 3 goes into 12 4 times, so I can estimate about 40. 41 times would be even closer, and I'd have 2 remaining. So if I were to rewrite that, it'd be 41 and 2/3. Okay. Again, if you couldn't quite do that mental math, 3 goes into 12 4 times. So if you did 40 times 3, that would give you 120. Another 3 would give you 123, and you'd need 2 more to get to 125. That's where you see this come in. Okay. So, big idea here. Remember your small rules for algebra. How do I undo what's being done to my variable? And then also keep flip-flop when you're dividing fractions. We're kind of mixing them all together now. All right, let's try B and C. They are very similar here. B says 7x equals 2/5. 7x equals 2/5. Ask yourself that question. What is being done to my variable, and how do I undo it? Well, it's being multiplied by 7. Okay, so how would I undo that? I would divide by 7 on both sides of my equation. 7 divided by 7 would be 1x equals, And then I just have to take 2/5 divided by, and 7 as a fraction is 7 over 1. And now you should be thinking to yourself, K, F, F, keep flip-flop, keep 2/5 the same, flip your division to multiplication, and flop this to its reciprocal of 1/7. That's what you can see that the book does here right away. Okay, so they say multiply both sides by the reciprocal of 7, which is 1/7. When you do that to the left-hand side, 1 times 7, 7 times 1 is 7, over 7 times 1 is 7. 7 divided by 7 is 1x. That's how they isolated their x. So they'll do, since they multiplied by 1/7 there, they'll multiply by 1/7 here. Essentially the same thing that I'm doing down here. Okay. Now I'll multiply across. On the top, I've got 2 times 1, which is 2. And on the bottom, I've got 5 times 7, which is 35. I'd get 2/35, and that answer is in simplest form. Okay. Lastly, we'll finish with letter C. It is similar. I've got 5/8 y. So this means 5/8 times y equals 6. Y and 5/8 are right next to each other, so that implies multiplying. To undo that, I would divide by 5/8 on both sides of my equation. Once again, dividing fractions, I'm thinking keep flip-flop and multiply by the reciprocal. Okay. Again, I divided both sides by 5/8. 5/8 divided by 5/8 here cancels out because it's 1, which is perfect. And now I've isolated my y. Y equals, okay, remember now, dividing fractions, multiply by the reciprocal. The reciprocal of 5/8 is 8/5. Okay, well, sorry, that I should put that over here. Multiply by 8/5 on both sides, because the reciprocal of 5/8 is 8/5. So once you do that, we get 6 over 1. Keep, flip, flop. All right. On top, I'd have 48. 6 times 8 is 48 over, on bottom, 5. 5 goes into 48 9 whole times. 9 times 5 is 45. So I'd have 3 left over to get to 48. Keep my denominator of 5. All right, there you have it. So a lot of work with keep, flip, flop, and undoing what's being done to the variable. Those are the two most important things here. All right, we're going to kind of break down a word problem here for the last example, or example number 2. And then we'll have a few check it out problems, and then we'll be done. So it says Dexter makes 2/3 of a recipe, and he uses 12 cups of powdered milk. How many cups of powdered milk are in the recipe? So to understand the problem, we're going to think that the answer will be the number of cups of powdered milk in the recipe. Okay, they want how many cups of powdered milk are in the recipe. List the important information. He makes, we're going to have to do this in a couple, maybe I can squeeze her all in one here. He makes 2/3 of the recipe. He's not making a full batch. And he uses 12 cups of powdered milk. So it asks how many cups of powdered milk are in the recipe. So if he uses 12 cups, and that's only 2/3 of the original recipe, we should expect in our answer that we find that in the original recipe, there should be more cups of powdered milk, because he's using 12, and that's only 2/3 of the original recipe. Write and solve an equation. Let x represent the number of cups in the recipe. That's what we're trying to find. That's why it's the unknown. he uses 12 cups, which is 2/3 the amount of the original recipe. So here is our equation. 12, what he uses, is equal to 2/3 of, so times the unknown, what we're looking for. All right, so let's solve this. What is being done to x? It's being multiplied by 2/3. So to undo that, I would divide by 2/3. And dividing by 2/3, remember, is the same as multiplying by its reciprocal. So that's 3/2. So multiply both sides by 3/2, the reciprocal of 2/3. All right, 12 times 3/2 and 2/3 times 3/2. Remember, this is just going to give you 1, because 2 times 3 is 6, and 3 times 2 is 6. 6 over 6 is 1. So that's why these will isolate our x. On the left-hand side, I'll make this a fraction. You can see they simplified before multiplying. They divided each of these by 2 to get 6 and 1. And then they multiplied across. 6 times 3 on top would give me 18. And 1 times 1 on the bottom is 1. So my answer would be there are 18 cups of powdered milk in the recipe. And remember, that's the original recipe. He only used 2/3. So 2/3 of 18 is the 12 that he used. Okay. Again, they're just double checking here. We got 18 for x. Let's substitute that back into our original equation and make sure that that works. So if I took 2/3 and I multiplied that by 18, 2/3 times 18 over 1. Could simplify this first. Dividing each by 3 would give you 6 and 1. And on the top, 2 times 6 would be 12, which, perfect, is our solution. Okay. So that was breaking it down a little bit for you. Hopefully that all makes sense. If not, feel free to come ask me. What I'll ask you to do now is pause the video to try the check it out section on your own here. All right. Hopefully you figured out j is being multiplied by 3/4, so you have to undo that by dividing by 3/4 on both sides, which is the same thing as multiplying by 4/3. Keep flip-flop. Okay. If you were to multiply across there, you'd get 76 over 3. Excuse me. And then if you wanted to rewrite that, 3 goes into 76. It'd be 25 times. 25 times 3 is 75. You have one more to get to 76. So 25 1/3 for the first one. And for the second one, Rich makes 2/5 of a recipe. He uses 8 cups of wheat flour. How many cups of wheat flour are in the original? So very similar to the problem that we just did, the word problem. And in this case, we say that he uses 2/5 of the recipe. Okay, so your equation, if you were to set one up, he uses 8 cups, and that's equal to 2/5 of the original, which we don't know, so we could call that x. All right, so to solve, we divide by 2/5 on both sides, or in other words, multiply by 5/2. 8 over 1 times 5/2, multiplying by the reciprocal. Simplify first. Divide each by 2 would give me 4 and 1. Multiplying across, numerator times numerator would give me 20 over 1, which is the same as 20. Since this is a word problem, I'll add my label. How many cups? 20 cups in the original recipe. And he only used 2/5 of it. So that's why he used 8. All right, that's all I have for today. Biggest things, keep working on that multiplying by the reciprocal, or keep flip-flop anytime you have a dividing by fractions problem. And also just a simple reminder of what is being done by a variable and how do I undo that when solving simple equations. All right, good luck with the homework, and I will see you next time.